Okay, so we're going to go over lesson 3.6. Okay, so starting with this first one, we're sketching the graph of the inequality. So we first want to get this in a form that is more familiar so we can actually graph it. Now notice how all these equations, they have a y in them. Okay, we want that y to be by itself. And to make it more familiar for what we usually graph, I'm basically going to flip this around so that the y is over here and that this 2x minus 2 is on this side. Now, notice it says that y is less than, so the y is smaller than this part of the function, so that when I flip it, I need to make sure that the sign still points the same direction at that y. So it's pointing here at the y, so when I flip it around, I want to make sure it's still pointing at the y. And then I put the 2x minus 2 here. And now if you look at it, it looks just like y equals mx plus b. So we can graph it just the same way. So here I'm going to start at -2, 1, 2. And then I'm going to use the slope, this number, to continue to the next point. So I go up 2 over 1, up 2, so we'll make 2 marks there, and then over 1. Okay, so I got just about enough points to graph. Now, remember that if it's a less than sign, it's going to be a dashed. If it's a less than or equal, it's going to be solid, the line. Okay, so here, in this case, it's just a less than. So I'm going to do a dash line with my arrows. Okay, and then the next part is the shading. Okay, so if I have a less than, okay, if y is less than or equal, we're going to shade below the line. Okay, whereas if y is greater or y is greater than or equal, then we shade above the line. Okay, which makes sense. Above, if it's greater than, we shade above. If it's less than, we shade below. Okay, so in this case, it says y is less, so we shade below the line. Okay, so remember, pay attention to what yours is. Okay, this is the example I'm giving you. All these examples are different from yours. Okay, here I'm going to do the same thing. I'm going to kind of switch these around. So y is greater than or equal to 4. Okay, now when all I have is a number by itself, there's no x, that means it's a horizontal line. Okay, if it were like x, maybe something like this, that's a vertical line where it's just x and a number. Okay, but again, right here we're just doing y. So this is a horizontal line at +4. So 1, 2, 3, 4. And now it has equal to, so I'm going to do a solid line going straight across. And then now I look at is y greater or less? It's greater, so I'm going to shade above. Okay, so now on this one, I want to solve for y. Okay, I'm going to solve for y. So I got to get the y by itself by getting rid of this 2x to begin with. So I'm going to add 2x on both sides. Okay. So now I have -5y is greater than, and I'm going to put the 2x first before the 10. Okay, then the next step would be I need to get rid of that 5, that -5, so I divide everything by -5. Now, when you divide by a negative number, no matter what type of inequality problem you're working on, you need to flip this sign. So this sign will go from greater than, now it turns to less than because it was a negative number, okay? Just because it was negative. So now I have -2 over 5x, and then 10 divided by -5 is -2. Okay, so now we have an equation that it's graphable. Okay, so we're going to start at -2. That's the y-intercept. Okay, then it goes down to and right 5 or over 5. So we're going to go 1, 2, and then over 5. 1, 2, 3, 4, 5. Go right there. Okay, and then I'm going to go backwards because going down 2 over 5 might not fit. So I'm going to go backwards. I'm going to go up 2 and over 5 to the left. So up 2, over 5 to the left side. And there will be my other point. Now again, pay attention to the sign. Here in this case, it's just less than. There's no equal sign. So dashed line this time. Okay, and then I look and see y is less, like this, so we shade under the line or below it. Okay, so what this is all saying is that when you're asking for the solution to this system, the answer to the equation can be anywhere in that shaded area. It could be anywhere. Okay, your answer could be here, could be here, could be here, anywhere. If the line is solid, an acceptable answer could be on the line itself. But if the line is dashed like this, the answer is not included. So for instance, this point right here is, let's see, 5 and -4. So you would say that's not a point included in the graph. It's not a solution to this equation, okay? Or if you pick a point out here that's out of the shade, that's also not a solution. It would have to be somewhere in the shaded area. Okay, so now let's do the same thing here. We want to get that y by itself, so we'll subtract x squared from both sides. Okay, and then we have negative y is greater than, I'm going to switch the negative x and 5. Okay, and it's positive 5 there, so plus 5. And then what I have to do is I have to get rid of this negative. So I'm going to divide by -1 to every value. Remember what I said back here? If I divide by negative, that means I have to switch the sign. That goes from greater than now to less than. This becomes positive x squared. This becomes -5. Okay, so now let's go ahead and graph that. Now remember, if it's x squared, that means I'm going to get a parabola. Okay, and it's positive here, so it's going to go up. It's a positive x squared, so I'll go 1, 2, 3, 4, 5. Remember, these are sketches, so they don't have to be perfect. So I'm just start here at -5. That's the vertex. Just kind of have it point up, nice as you can make it. All right, now it says y is less. So we're going to shade under. Oh, and I'm sorry, I think I just did that wrong. I wasn't paying attention to the sign in that it's just less than, so I should have been making a dashed line. So dashed line going both ways. Okay, now again it says y is less. So we're going to shade under is down here. So pretty much everything on this side of the parabola. Okay, that's how you shade that. Okay, so now on these ones, we're going to use Desmos. So I want you to go ahead and use Desmos for this one. So basically, just graph these. Go to Desmos and graph these. Y, I'm going to hide this little thing here. Okay, so then y is, what do we got? Greater than or equal. So that's right here in Desmos. And then the absolute value of x. And then over here is minus, so -3. Okay. And then notice how it shades it automatically. Okay. It'll shade it for you. I'm going to turn that off for right now. And then y is less than negative, absolute value of x. Y is less than or equal to the negative absolute value of x. Oops, I don't want all that. I think it was a +5. Okay, so +5. Okay, so that's how you type them in. And notice, that, again, if I do one at a time, it automatically shades everything for me there. Okay, same thing here. Now, if I turn them both on, notice it kind of shows you that overlapping area where they're shaded at. So I'm going to need some points to graph it. So what you're going to do is take some of these points that you see here, some of these solid points that are whole numbers, graph those, and use that to fill in your graph for the rest of that problem. Okay, and then you're going to describe what is the shape that is formed from that. So you guys answer that question. All right, so now this one we're going to sketch this system, and then we're going to form the solution as one. So now we're dealing with two inequalities. So first one, we're at +2, and this one points down, and I know that because it's negative. And also I have to remember that that's a solid line because of the equal to sign. So just a quick sketch of a solid line, solid parabola going down. Okay, now this is also a parabola, and you can see that the vertex is at -2 and -3. And again, I knew that this parabola starts in the middle because the vertex of this one is 0, 2. Since there's nothing in the parentheses there, You know that first number is 0. Okay, so this one starts at -2 and 3 and -3. And then this one's positive in the front, so this one goes up, and it's a solid line. So then I just kind of do my best to make a parabola pointing itself up. Now, I'm going to start with the first equation and figure out the shading. Okay, so shading, y is greater, so that means that for this first one here, that I would shade everything above that graph that's pointing down. Now what I'm doing is I'm shading very lightly, okay? And then wherever the shade crosses over with both graphs, that's going to be our solution. All right, so now this one is y is less than this graph right here. Y is less than, so that means that everything below this graph right here is shaded. So that means like down here. And actually what I'm going to do is I'm going to extend this off of the graph. That way it's a little easier to see where I'm shading at. Okay, so that means everything below that graph there. Okay. And notice it's not in here. They're not shaded together here. And they're not shaded together here, but they're shaded together right in this area, kind of on the outside of the graph there, and over here as well. So this region is the area I want to darken up, because that's where they're both shaded at. Okay, you can confirm that with Desmos if you want. Okay, so now on the next page, this one will be the same as the last problem. So you're going to graph those here. And you can kind of check yourself with Desmos as well. Okay, so now we're going to sketch this one. The locator point, this is a cubed. Okay, so this means this is going to be the graph that looks like this. Okay, so the vertex or locator point, as we call it, the middle of the graph is at -3, 2. So -3 and +2. All right, so now I'm going to do a quick sketch. Now remember, that is a dashed line. So I'm going to do my best to make a dashed line here. All right. Now it says that y is greater. Okay, so now where y is greater, notice how it kind of slants a little bit here. It's almost kind of flat. So above that middle point, that is the shaded area here. So that means everything on this side of the line is above the line. So that would be my shaded reason. That's my answer. Because remember, I'm only shading one area since this is just one graph. Okay, so now here, if you might recognize I have an x squared and a y squared, so that means this is going to be a circle. Okay, so that means I have my center for, and remember, guys, use your equations, don't use mine, or use your inequalities. My center is at -4 and 2. And then my radius, remember I take the square root of that number, so it's going to be 5. Okay, or the square root of 25, which equals 5. Okay, so I'm going to start with my center at -4 and 2. Okay, and then I'm going to write, and then I'm going to put some points for the radius. I'm going to count out 5 all the way around. So 1, 2, 3, 4, 5. 5, that right there. 5, 5. Okay. Now I got to pay attention. First of all, that is a dashed line, so I'm going to make a dashed circle. Notice that yours is equal to, so yours is going to be different. Now, if it is less than, if you see that this whole part is less than, okay, then that means we are going to shade inside the circle. Inside the circle. Okay. If this were the other way, that means we would shade outside the circle. So this one, since it shows that it is greater than, it will be outside the circle. Okay, that's kind of the quick way of doing that. All right, so now we're going to graph these. These are absolute. This is an absolute value graph. Okay, so the vertex of this absolute value graph is at 1 and -4. And remember, absolute value graphs have a V shape. Okay, So I'm going to start at 1 and minus 4. Okay, and unless that number in the front, and again, this is just me knowing what an absolute value graph looks like, unless that number in the front is more than 1, the slope of the lines is going to be 1 over 1. So whatever that number in the front of the absolute value is, that tells you the slope of the line. So since there's nothing there, it's up 1 over 1. So for instance, if that was like a 2 right here in the front of it, it would be up 2 over 1, just like one of these types of equations. So I would go up 1 over 1, and I can kind of just keep going that way. All right, and I don't need a ton of points. I just need enough to make the graph. Okay, so now here it's equal to, so it's a solid line. Okay, so remember, after you graph it, you got two things you got to think about. Is it a solid or dashed line? And then the last part, do I shade above or below? It says y is less, so I'm going to shade below. Okay? All right, so now this one, I got a system. So first we'll start with this one. Let's start at -2. This is going to be a straight line, whereas this one's going to be a parabola that points down, and I know it's down because that's negative. Notice yours is not, so yours would point up. Okay, so let's start with the line. Okay, this is y equals mx plus b. So my b, y-intercept is -2. And I go up 1 over 3, up 1 over 3, up 1 over 3. And I'll go down 1, left 3, down 1, left 3. Okay, and that's going to be a dash line. Okay, now the next one, first let's get the vertex. The vertex of that parabola would be at 1 and 2. So 1 and 2. And it's pointing down, and it's solid. It's a solid line. Okay, so now it's time to shade. Okay, so now for the first one, you're going to shade one at a time. Y is less than, so everything below the line is like what I'm going to shade. Now remember, I want to shade very lightly. Okay, shade very lightly, and then you're going to darken up the area where they're both shaded at. And then for the parabola, it's y is greater than, so that means pretty much outside of the U shape is going to be greater than. So everything kind of above here on this side of this U. So notice how here is where it's starting to get overlap. So I'm doing everything under the straight line, but then to the outside of the U. Same thing over here. I would shade lightly here, but then here, as soon as I go under the line, that's where they overlap. And that's where the area that I want to shade. So it ends up being these two zones kind of out here, which is under this line, but then on top of or outside of the U on this line, since its y is greater than. All right, that's it.